10.4 practice problems. Answer key. A lot of work here, but I think that has to be expected. Find the value of x, which equation is an identity. So I look at this and I go, I don't know what's going on. Let me try. This is geometric. We're multiplying up by, oh wait, no, it's obvious what's going on. First term is 1. We're multiplying by x plus 5 every time. Well, then what is a negative 1 here? Seems a bit odd. Well, let's just see what happens. If r equals x plus 5, then is sum 1 over 1 minus x plus 5, which is 1 over 1 minus x minus 5, which is 1 over negative x minus 4, which is the same as negative 1 over x plus 4. All right, so now that I got that part done, all right, so we know that x plus 5 is less than 1, negative 1 less than x plus 5 is 1, subtract 5, negative 6 less than x less than negative 4. Find the value of x, which equation identity. There it is. All right, same thing. This one hasn't changed at all. So it's just, I mean, that's our geometric series. So absolute value of x has to be less than 1, negative 1 less than x less than 1. Fun. These are comparison tests. So what are we going to compare to? We compare to E almost every time. So it's a terrible problem. If you don't want to do it, don't. I don't have any problem with it. X to the 3n over, that's weird, 2n factorial plus 1 is less than or equal to x to the 3n over n factorial. We're doubling and adding, making a bigger denominator. So the bigger denominator than this, so the fraction is smaller, which is, yeah, whatever. X to the 3rd to the n over n factorial. So the sum, what am I asking for? Show that the series converges. Yeah, so this is sum from n equals 0 to infinity. X to the 3rd to the n over n factorial, which we know is e to the x to the 3rd. And we know that converges for all x. What a pain. Okay, here we go. Exact same problem. X to the 2n over n factorial plus 2 less than or equal to x to the 2n over n factorial. I'm not writing y because it's the same answer as before, which is equal to x squared to the n over n factorial, which this is sum n equals 0 to infinity, x squared to the n over n factorial, which is e to the x squared, which converges for all x. Alrighty, show the series converges absolutely, meaning I don't need an alternate series, whatever. All right, let's see. Okay. Again, I don't like this. I should have just cut these problems out. Cosine of x to the n over n factorial plus 1 less than or equal to. Notice the only difference between the top and the bottom is that we just get this absolute value thing going on. Cosine of x to the n over n factorial, which is less than or equal to 1 over n factorial. Converges to E. Yeah, we put in 1 for x, no matter where we put it. All right, that makes sense. Over here, you're probably like, oh, it's the exact same problem. It's a little different. Sine of x to the n over n factorial plus 3 less than or equal to 2 sine of x to the n over n factorial less than or equal to 2 over n factorial. 2 over n factorial converges to 2e. Find the radius of convergence. Hey, that means we are doing ratio tests, which is challenging, but you know, what we get paid for. So limit n goes to infinity. Notice this just tells me to do this. These two have nothing to do with each other. Alrighty. I always forget the absolute value, so let's put that in this time. X plus 5 to the n plus 1 over x plus 5 to the n, which is the limit n goes to infinity of x plus 5. And off we go. There's no n left. X plus 5. So x plus 5 less than 1. I'm jumping to the end of the story here. -6 less than x less than -4 is my radius convergence. Pardon me, is my interval of convergence. And my radius, therefore, is 1. The radius is right here. I don't even need to do this. But I'm a thorough person. Limit as n goes to infinity. (3x minus 2 to the n plus 1 over n plus 1 n over 3x minus 2 to the n equals limit as n goes to infinity. No, I gotta start cutting to the chase. N over n plus 1 is 1. 3x plus 2 n plus 1 over n is 3x minus 2. I don't know why I wrote this twice. Is 3x minus 2. 3x minus 2 less than 1. And 1 less than 3x minus 2 less than 1. 1 less than 3x less than 3. 1/3 less than x less than 1. Radius is 1/3 because this gap is 2/3 big and you cut it in half. Limit n goes to infinity. N plus 1. X to the n plus 1. N plus 3 times n plus 2 over n, absolute value x to the n, equals limit as n goes to infinity. This cancels to 1 and this cancels to 1, so they're all gone. This cancels to x to the n. All right, I gotta think this one through for a minute. Yeah, that's it. It's too easy for me. Not to x to the n. X to the 1. As the value of x less than 1, negative 1 less than x less than 1, radius equals 1. Limit n goes to infinity. X to the, careful here, this gets goofy, to n plus 1 plus 1. N plus 1 factorial, n factorial. X to the 2n plus 1 equals limit as n goes to infinity. N factorial over n plus 1 factorial is going to just be n plus 1 on the bottom. Looks like I screwed up. Hang on, I got to think this one through. Let's look at the top. So absolute value. 2n plus 2, 2n plus 1 is going to be x squared. Over n plus 1. Oh, my notes are wrong. All right, so what's going on? N's going to infinity. This goes to 0. No matter what I put in for x, it's a set number. 1 billion eventually, this will get way past it. 0. All right, so if it's 0, that means converges for all reals. And the interval convergence is infinity. Wow, tricky stuff. Okay. Limit as n goes to infinity. Here we go. N plus 1. Absolute value of x to the n plus 1. 4n plus 1. N plus 1 squared plus 1 times, holy moly, 4 to the n squared plus 1 over n x to the n equals n plus 1 and n, see ya, 4 and 4n plus 1 gives me a 4 on bottom. Absolute value of x to the n plus 1 over x to the n squared plus 1 over n squared plus, that's gone. So gone, 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 gone. Holy mackerel. Equals absolute value of x over 4. Absolute value of x over 4 has to be less than 1. Absolute value of x has to be less than 4. Negative 4 less than x less than 4. R equals 4. I might have gone off screen again. Good. Okay, this looks ugly, but let's see how it goes. Equals limit as n goes to infinity of square root of n plus 1 times absolute value of x to the n plus 1 over 3n plus 1. 3 to the n, square root of n, absolute value of x to the n. This is getting tiresome. Equals limit as n goes to infinity Square root of n over square root of n cancels because they're both the same power, 1/2. This will leave me with a third on the bottom and an x on top. Absolute value of x over 3. Absolute value of x over 3. Absolute value of x over 3 has to be less than 1. Absolute value of x less than 3. Negative 3 less than x less than 3. R equals 3. All right. Okay, find the radius convergence. Same deal. Limit as n goes to infinity. 4x minus 5 to the 2n plus 1 plus 1. N plus 1 to the 3 halves. N to the 3 halves. N to the 3 halves over absolute value 4x minus 5 to the 2n plus 1 equals limit n goes to infinity. N to 3 half, n to 3 half. See ya. 2n plus 3 eventually, 2n plus 1. So absolute value of 4x minus 5 squared, which is just 4x minus 5 because it's squared, so it's always positive. All right, we know where this goes. You end up with 4x minus 5. If you take square root of 1 has to be less than 1. Negative 1 less than 4x minus 5 less than 1. Add 5 to both sides, we get you know what, I'm just going to run with this. 4 less than 4x less than 6. Divide everything by 4, and we get radius convergence. 1 less than x less than 3 halves. R equals, this is 0.25, 1/4. Because this gap is 1/2. Equals limit as n goes to infinity. Absolute value x minus root 2 to the 2n plus 1 plus 1. 2 to the n plus 1, 2 to the n. Absolute value x minus root 2 to the 2n plus 1. Equals limit as n goes to infinity. We'll have a 2 on the bottom, and we'll have a x minus root 2 squared over 2. Throw out the absolute value because it's being squared. X minus root 2 squared over 2. Alrighty, multiply both sides by 2 and then take the square root. So we end up with absolute value of x minus root 2 has to be less than square root of 2. Wow, this is fun. Negative root 2 less than x minus root 2 less than root 2. Add root 2 to everything. 0 less than x less than 2 root 2. R equals root 2. Crazy stuff. Problems 15 through 17, find the interval of convergence and the sum of the series as a function of x. We're adding this up, it's geometric. So this has to be geometric series. This gets weird, just be aware. So n equals 0, the first term equals 0. Plugging 0, we get 1. To 0, we get 1. First term doesn't equal 0. First term equals 1. naughty, equals 1. It's updating by r is x plus 1 squared over 9 every time. So the interval of convergence, we do that whole thing with -1 is less than, no, I forgot to do it all the other way. X plus 1 squared has to be less than 9. We multiply it by 9. And then we take square root. We get -3 less than x plus 1 less than 3. -4 less than x plus 1 less than 2. There's my interval of convergence. Does it ask for the radius convergence? It does not. If I wanted to, I'd write r equals 3. And then the sum, 1 over 1 minus x plus 1 squared over 9. 9 over 9, flip it, we end up with 9 over 9 minus x squared minus 2x minus 1, distributing the negative, equals 9 over negative x squared minus 2x plus 8. Tricky stuff. All right, so this is a geometric series also. N equals 0, first term equals whatever x is, as long as it's part of the right numbers, 1. Weird. R equals ln of x, interval of convergence, absolute value ln of x less than 1. Break it into 2. Ln of x cannot be negative. Yeah, whatever. Ln of x can be less than 1, or ln of x can be greater than -1. Here we get x is less than e. Here we get x is greater than 1 over e. So we get 1 over e less than x less than e. Good luck finding your interval of convergence. And your sum, 1 over 1 minus ln of x. All right. Geometric series. R equals sine of x over 2. First term again is 1. Don't know why I didn't write that this time. N equals 0. Oops. First term 1. IOC sine of x over 2 is 1. Sine of x less than 2. Sine of x is always less than 2. Absolute value of sine of x is always less than 2. So negative infinity less than x less than infinity. You can put anything you want in here. It's going to work. Yeah, I knew that. And then the sum, 1 over 1 minus sine of x over 2, common denominator flip, 2 over 2 minus sine of x. Done. Okay, determine the convergence or divergence of the series, identify the test or test you use, so on and so on. All right, so I'm going to do this one twice. Nth term test. What's going on here? Well, the limit as n goes to infinity of 2 to the n over n plus 1 is infinity. This gets bigger, but this gets crazy bigger if I do a L'Hopital's. This goes to 1, so this fails. So this diverges, done. However, if you said I want to do a ratio test, fine. You would do the whole limit as n goes to infinity of 2 to the n plus 1 over n plus 1 times n plus 1 over 2 to the n. These cancel, and we're left with 2. 2 is greater than 1. So therefore it diverges. Over here we have a geometric series. It's 1 over 8 is the r, and the first term is -1. So the first term is 1, -1. R equals 1/8. R is less than 1, converges. So over here, let's try the nth term test. Limit as n goes to infinity of n sine of 1 over n equals infinity times 0, which we've often been told, hey, I don't know what's going on. Well, let's L'Hopital rule it. We'll make this 1 over n. So we get sine of 1 over n over 1 over n. We do the derivative there, and we get, sorry, that's 0 over 0. So I can do L'Hopital's rule. We do the derivative there, we get cosine 1 over n -1 over n squared over -1 over n squared, thea. So we get, all right, let's do it again. What's the limit as n goes to infinity of cosine of, 1 over n? That's freakishly large number. It's cosine of 0, which is 1, which means we don't know. All right, so that's the nth term test. Oh, wait, no, that's ratio test we would get. So basically out of infinity, we're adding up 1, it has to be 0. Look how confusing it gets. So that means it diverges. If we're going over here, oh, for goodness sakes, I apologize. Walk through that again. So L'Hopital's rule, sine of 1 over n. I throw the 1 on the end of the bottom, 0, 0. Okay, we can do L'Hopital. Derivative of sine is cosine with that part. Derivative of that is that part. They cancel. So the limit as n goes to infinity of cosine of 1 over n. Put an infinity, get 0. Cosine of 0 is 1. This is not the ratio test, it's the nth term test. We're adding 1 plus 1 plus 1 out here at infinity. It diverges. Let's do ratio test up here. Limit as n goes to infinity of n plus 1 to the 10th over 10 n plus 1 times 10 to the n over n to the 10th. These are both to the 10th power, so they're gone, and we end up with 1/10. No absolute value, no x's, all that nonsense, so done. 1/10 is less than 1, converges. Down here, sum of 1 plus 1 over n is e to the x, I thought. No, not quite. It's close. All right, so let's do nth term test. Limit as n goes to infinity, 1 plus 1 over n, so I get an ln it. So I get n ln of 1 plus 1 over n to the n, which means I have to go with limit as n goes to infinity of ln of 1 plus 1 over n. There should not be an n up here. That's the whole reason I did that. Over 1 over n. That gets me 0 over 0. Infinity is 1, ln of 1. Infinity is 0, ln of 1 is 0. L'Hopital's rule, 1 over 1 plus 1 over n. Times chain rule, negative 1 over n squared. I think I found a mistake in my notes. Times chain rule, negative 1 over n squared. Limit as n goes to infinity, 1 over 1 plus 1 over n. That's 0. We get 1 diverges. Because again, we're doing the nth term test. Nth term test for this one. Sorry, my hands are starting to cramp up. So limit as n goes to infinity, n factorial over e to the n is infinity, which means it diverges. You might say it's infinity over infinity. I happen to know that the factorial goes faster. Prove it. All right, fine. Ratio test. Limit as n goes to infinity, n plus 1 exclamation point e to the n plus 1 times e to the n plus 1, oops, n factorial equals limit as n goes to infinity, n plus 1 over e. Limit infinity keeps getting bigger and bigger and bigger, just stays at e, equals infinity, which means it diverges. Wow, this is freaky, lots of work. All right, 3 to go. Term of convergence, divergence, identify the test, blah, blah, blah. Well, this is a geometric. And the R value is negative 2 over 3. So negative 2 over 3 is less than 1. Absolute value is less than 1. So bang, we're done. Converges. Let's do ratio test. Limit as n goes to infinity, n plus 1, ln of n plus 1 over 2 to the n plus 1 times 2 to the n over n times ln of n. ln of n plus 1 and L of n are going to cancel. N plus 1 and n are going to cancel, and we're just going to be left with 1/2. 1/2 less than 1 converges. Alrighty. Let's do ratio test. And limit n goes to infinity. N plus 1 factorial over 2n plus 1 factorial times 2n plus 1 factorial over n factorial equals limit as n goes to infinity of n plus 1. This is 2n plus 2, 2n plus 3, 2n plus 1. So this is, unless I'm very mistaken, right, the 2n plus 2 times the 2n plus 3. Yeah, okay. So on the bottom we have 4n squared. All right. It seems a little weird, but we have two of them here. 2n plus 2 plus 1 is 2n plus 3. So it's 2n plus 2 term plus 2n plus 3 term. This goes to 0. So we're squaring that, and it's getting freakishly bigger. 0 is less than 1. Converges. Holy cow, what a nightmare, huh? Hope you enjoyed that as much as I did. Not